Hello, good noon, my dear students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry, NEET GOC one shot. In the previous class, we discussed about NEET GOC one shot. A few topics are left, very important topics, that are electronic effects. We did IUPAC nomenclature and isomerism in all aspects, and get ready for the electronic effects and the applications of electronic effects. In today's class, NEET most important organic chemistry backbone we are going to discuss. So, entire organic chemistry is all about more than 30% to 35% for the NEET paper. So, for all the 30-35% of the organic chemistry, it is the backbone of this is going to be general organic chemistry. Get ready. Please confirm, can you all able to see me, can hear me? Yes, that's good. And this session is awesome, and I can guarantee you that those students who are preparing for NEET 2025, this session is going to be super important and helpful to you. So, let's see. Before going for that, little promo. So, GOC NEET one shot and oath of the day, crack your NEET examination, nothing more than that. For that, everybody, please like and share and subscribe to Infinity Lane YouTube channel, and in the Google App Store you can see Infinity Lane app. There you can going to download Infinity Lane app, where you are going to access live classes, mock test, and create your own test on 24/7 doubt resolution sessions. So, dear students, everybody get into that. Whenever you are preparing for an examination, it is required to understand where exactly you stand and how you are doing. For that, you need a specifically scientifically designed assessment platform, that is NEET 2025 All India Test Series from Infinity Lane. And so, benchmark yourself against India's the best assessment platform, and 34 syllabus, full syllabus test, and usme 14 grand tests, 20 mock tests are there, and detailed video solutions are available for each and every test. And enroll now in the description box, it is given, and in the description box you click that link and you are going to see it was 5,999, now you are going to get 11,999, and 80% discount. Isse sasta aur kaun dega. So, please follow the link and you can enjoy seamless preparation for NEET examination, my dear children. And the topics that we are going to see in the general organic chemistry promo is over. Take a pen and paper, everybody work with us so that you are going to get a boost up your confidence level. So, isomerism and electronic effects, and acidic strength, basic strength, and reaction intermediates, and these are the core point of this general organic chemistry issue completed. Isomerism, IUPAC nomenclature and isomerism is already completed, and we are going to discuss these things with in today's class: basic strength, acidic strength, electronic effects. Okay, Violet, take a pen and paper and solve along with us if any question is coming. And more important, if you have any specific doubts related to the current context, generously you can use the chat box, and you can disclose your doubts in the chat box so that we can have a very good discussion about this NEET preparation, general organic chemistry. Violet, directly we will go into the electronic effects without any delay. So, the time is also very important, my dear children. These slides has been completed on the other day, and get ready. Here it is. Yeah. Electron displacement effects. Dear children, in the electron displacement effects, you have inductive effect, electromeric effect, mesomeric effect, and hyperconjugation. And we will be discussing about in detailed version of these effects and their applications also. So, their applications can give you the insight of how a chemical reaction takes place in the organic chemistry. Dear children, let's jump directly into inductive effect. What is inductive effect? It is simple, as simple. For the inductive effect, the key point, that is difference in the electronegativity. And the organic compound, you are going to have the carbon chain. Yes, it is a carbon chain in the organic compound. If this carbon chain is attached to some element or some group, let us say chlorine over here. So you see there is a sigma bond between this carbon and this halogen. Let it be halogen or any other functional group. Chiranshu, hi, good afternoon. And because of the more electronegativity of this, it is going to pull the electron more towards the chlorine, so that it is going to have partial negative charge. It is going to have a partial positive charge. So what happened, because of this induction of this, the sigma bond is little transmitted in this way. It is going to have a partial positive charge, and it is going to be like this, a little positive charge. So the magnitude of the negative charge on this chlorine is equal to the sum of the magnitude of the carbons that is seen on these 3 carbon atoms, and after 2 to 3 carbon atoms this is going to be completely disappeared. So dear students, take a pen and paper, everybody follow with us, and let us say the other way. When this carbon chain is attached to some group or an atom, that is you can say Z, and where you can see this carbon is more electronegative than Z, that is the key point over here. So that electron is pulled more towards the carbon, so that what happened, it is going to have a negative charge, rather it is going to have a positive charge. ये negative charge and a positive charge का वजह से, negative charge and a positive charge का वजह से, so it is going to be like this. Yes, what is the basic difference between these two? Yes, electron is withdrawn in this way from the carbon chain, electron is pushed in the way towards the carbon chain. Am I right? So this is what you can say negative inductive effect, and this is what you say positive inductive effect. So this positive inductive effect and negative inductive effect. So this effect has some magnitude and some effect like this. What are the applications of this? What is the order we can say? So simple, I just want to give you minus I series electron withdrawing group. This is the order, NR3 plus is greater than NO2, CnF carboxylic group, and carbonyl, chlorine, bromine, iodine, OH, OR, C6H5. I just want to say, what about all the functional group, whatever you know, it is all depends on, it is related to minus I group, okay. And talking about plus I group, so is it important to memorize which is minus I, which is plus I? सारा का सारा फंक्शनल ग्रुप जो है ये माइनस एम आई का है, एंड बाकी जो अल्काइल ग्रुप है दे आर प्लस आई का है, and oxide and carboxylate only comes before that. They are going to have positive inductive effect. So it is important, I just want to say minus I effect is directly proportional to the electronegativity of the group or electronegativity of the atom. That is the simplest trick that you can say. Chiranshu, Chinrasu it is given. And positive inductive effect jo hai na, it is directly proportional to size of alkyl group. And of course, deuterium is greater than hydrogen. That is also one important thing. And this inductive effect, let it be positive inductive effect and negative inductive effect. It is distance dependent. That is important. Distance dependent. I mean to say, inductive effect is inversely proportional to distance. और एक इम्पॉर्टेंट चीज है, हाय अंकित सिंह, एंड इट इज आल्सो वेरी इंपॉर्टेंट, सिर्फ सिग्मा बॉन्ड उसमें इन्वॉल्व किया जाएगा, pi bond will not be involved in that. ठीक है. एंड वेन एवर आप इंडक्टिव इफेक्ट बारे में इस्तेमाल करना चाहता हूं, ये जो कॉन्सेप्ट में, ऑलवेज यूज डीएनपी रूल. व्हाट इज दिस डीएनपी रूल? सो डिस्टेंस इज ग्रेटर देन नंबर इज ग्रेटर देन पावर. ये पावर किस चीज के बारे में? दिस इज द इंटेंसिटी ऑफ द इंडक्टिव इफेक्ट. अंकित सिंह, नाउ यू कैन से ऑलवेज डीएनपी रूल इस्तेमाल करो, चाहे आपको एसिडिक स्ट्रेंथ है, बेसिक स्ट्रेंथ है, स्टेबिलिटी ऑफ कार्बोकैटायन, व्हाटएवर. सो eventually you are going to understand how to use this inductive effect. And last but not least, एक important चीज है, this is the weakest effect. It is the weakest effect. सबसे जो है, and these are all the various electronic effect. ये electron effects में आपका आता है. So hydrogen bond, is greater than steric factors, is greater than aromatic, then resonance, then hyperconjugation, then inductive effect. इतना सारे चीज का है ए वाला रेजोनेंस, हाइपर कॉन्जुगेशन, इंडक्टिव इफेक्ट और द इलेक्ट्रॉनिक इफेक्ट्स. एंड दीज आर ऑल नॉट द इलेक्ट्रॉन डिस्प्लेसमेंट इफेक्ट्स. बट व्हेन इट कम्स टू द एप्लीकेशन, you apply hydrogen bonding is greater than steric factor is greater than aromatic effect, then resonance and hyperconjugation and inductive effect. That is the actual order you have to follow. सबसे कम वाला है इंडक्टिव इफेक्ट होगा. माइंडेड, ये दिखा देते हैं आपका इफेक्ट में, लेकिन स्टेरिक इफेक्ट, एरोमेटिक इफेक्ट अब ढूंढना पड़ता है. आर यू गेटिंग और नॉट? नाउ लेट अस गो एंड सी द एप्लीकेशंस ऑफ इंडक्टिव इफेक्ट. इन दिस एप्लीकेशंस ऑफ इंडक्टिव इफेक्ट, effect of electron withdrawing group and electron releasing group on acidic and basic strength है सबसे पहला वाला है. Electron withdrawing group increases acidic strength and decreases the basic strength. Electron releasing group decreases the acidic strength and increases the basic strength. So I just want to give you by using this. चाहिए ये जो सब है ये कार्बोक्सिलिक ग्रुप का है. So ये कार्बोक्सिलिक ग्रुप, let us say a weak acid, it is Ha, it is going to give you Hu plus and A minus. So acidic and a basic strength are the things which are related to ionic equilibrium. So ionic equilibrium चाहिए ये acid का acid dissociation constant Ka आना है. Ka is equal to H plus and A minus and Ha. इसमें जहाँ पर H प्लस कॉन्सेंट्रेशन ज़्यादा है, इसका Ka वैल्यू भी ज़्यादा होना चाहिए. सो एसिडिक स्ट्रेंथ बढ़ते जाएगा तो Ka वैल्यू भी बढ़ते जाएगा. सो सबसे ये A माइनस का स्टेबिलिटी का ऊपर डिपेंड करना है. सो दैट यू कैन सी हियर इट इज गोइंग टू बी A कॉन्जुगेट बेस. A माइनस इज सेड टू बी ए कॉन्जुगेट बेस. सो इट इज सेड टू बी ए कॉन्जुगेट बेस. जहाँ पर एसिडिक स्ट्रेंथ is directly proportional to stability of conjugate base. So चाहिए ये माइनस ई ज़्यादा स्टेबल हो, सो दैट इक्विलिब्रियम हमेशा आगे बढ़ने का कोशिश करता हूँ ताकि ये स्ट्रॉन्ग एसिड बनेगा. आर यू गेटिंग और नॉट? Always remember acidic strength is directly proportional to stability of conjugate base, and as acidic strength increases, Ka value increases and its pKa value decreases. That is important point. Okay. Now we can see, compare the acidic strength of this formic acid, acetic acid, propanoic acid, isobutyric acid. Can you please tell me which is a strong acid? You can use chart box. you can use short box and discuss with us. So that I am going to tell you how to solve this. Hi, Tribeni Roy, very good, very good. I can say 4 is greater. How do you say 4 is greater? चाहिए ये वाला. Tribeni Roy, happy to see you. So, in these YouTube sessions, I found students who are attending my classes on a regular basis. So Tribeni Rai is one student attending our classes on a regular basis, really helpful to you. Okay, anyways, this is the answer for this. So, hydrogen is taken as a standard and methyl group इसका positive inductive effect का वजह से acidic strength इससे कम होगा. Okay, so acidic strength इनवर्सली प्रोपोर्शनल टू पॉजिटिव इंडक्टिव इफेक्ट है ना. यहाँ पर और ज़्यादा पॉजिटिव इंडक्टिव इफेक्ट है, दिखाई दे रहे ना, है कि ना. यहाँ पे भी और ज़्यादा है. जहाँ पर ज़्यादा पॉजिटिव इंडक्टिव इफेक्ट है वहाँ पर एसिडिक स्ट्रेंथ कम होने का संभावना है. सो दैट हियर 1 इज ग्रेटर देन, 2 is greater than, 3 is greater than 4. So 1, 2, 3, 4 is the answer for this question. Tribeni, उल्टा के लिख दिया. Okay, so for NEET examination preparation, it is a sad story. Many of the students know the concept very well and they attend the question nicely and solve the question in a good manner, and when you give the proper answer ना उल्टा पुल्टा हो जाएगा. Okay, take care of that. It is not only Tribeni का problem है, majority of the students does this same type of mistakes. So आज हमारा ये practice session जो है ना उसमें ऐसे problems आने का भी है. ये उल्टा किया. No, don't say sorry, learn. ओके, सीखने का कोशिश करो बेटी. ओके त्रिवेणी, अगले क्वेश्चन. एंड हियर यू कैन सी एसिटिक एसिड, उसमें क्लोरोएसिटिक एसिड बना दिया, नेगेटिव इंडक्टिव इफेक्ट. फ्लोरोएसिटिक एसिड बना दिया, नेगेटिव इंडक्टिव इफेक्ट. सो इंडक्टिव इफेक्ट, एसिडिक स्ट्रेंथ is directly proportional to negative inductive effect. ये नेगेटिव इंडक्टिव इफेक्ट फ्लोरीन का ज़्यादा होगा आयोडीन का कंपेयर करने तो. सो फ्लोरीन इज मोर, सो 3 is more than 2 is more than 1, right? Any doubt? Now let us use one more. And alcohols also acidic. Alcohols also acidic. So let it be, it is acidic nature of carboxylic acid, acidic nature of phenols, acidic nature of alcohols, acidic nature of any substance is depend upon how freely it can give H plus. Once it is given H plus, it is going to form a conjugate base. So we have to check the stability of the conjugate base. Okay, if you use this H plus and O minus and H plus O minus and H plus O minus. Now we can say this O minus is already negative. He is pushing the electron by means of inductive effect, right Tribeni? Now we can see this negative is pushing the electron by means of positive inductive effect. Now we can see this is the negative one and it is pulling the electron by means of 3 fluorines. So that already negative, he is taking out the electron, so 3 is going to be more stable once it is forming a conjugate base. So इसी के कारण 3 is greater than and 2 is the less, सबसे कम से कम 2 होगा, ज़्यादा से ज़्यादा option 3 होगा. So 3 greater than 1 greater than 2. So here acidic strength 3, 1 and 2 and Ka value 3, 1 and 2 and pKa values 3, 1 and 2. Are you getting or not clear? Tribeni, अगर कुछ डाउट है ना तो पूछना. जल्दी। And find out the next question. Find out the next question. Here it is. I want to see. Find out the next question. सेशन में सर
हाँ मैंने बोला था सेशन में।
Here you are going to have a positive inductive effect. Here going to have the sp3 carbon का है, and here it is an sp2 carbon का है. So sp2 is more electronegative than sp3, so that it is going to have negative inductive effect. And here it is going to be sp carbon का है. sp carbon is more electronegative than this, so that it is going to be super electronegative as compared to this, right? Now it is a collection of sp2. These are all sp2. It makes this is more and more negative inductive effect. Understand? Acid fundamental. Wonderful. So based on the minus I series, the order of the acidic strength 4, 3, 2, 1. ठीक है? Next, so let's see how to do this. By looking at this, these are the carboxylic groups. Based on this carboxylic group, पहले कौन सा group लगा है? So this is having a positive inductive effect, and this is going to have a negative inductive effect, and this is also having a negative inductive effect, and this is also having a negative inductive effect. So negative inductive effect, जो भी inductive effect है ना, is inversely proportional to distance. Negative inductive effect is inversely proportional to distance. So here it is very close. A carboxylic group का क्लोरीन बहुत नजदीक में है ना, सो इसमें इंडक्टिव इफेक्ट ज्यादा से ज्यादा होगा, एंड इट इज लिटिल फार अवे, थोड़ा सा दूर के जाने के बाद इंडक्टिव इफेक्ट यहाँ पर कम होगा, एंड यह बहुत दूर में है, इंडक्टिव इफेक्ट कम से कम होगा, सो दैट लेकिन होगा. सो ये वाला पॉजिटिव इंडक्टिव इफेक्ट है. सो दैट आई जस्ट वांट टू से इट इज क्लोज, 2 इज ग्रेटर देन 3 is greater than 4 is greater than 1, कम से कम होगा एसिडिक स्ट्रेंथ के बारे में. आर यू गेटिंग और नॉट? क्लियर? या त्रिवेणी, आस्किंग योर डाउट्स? यू आर नॉट आस्किंग डाउट्स? जल्दी. क्लियर? नाउ और थोड़ा आगे बढ़ दो. वंडरफुल. नाउ so far we have seen the acidic strength and we are going to see the basic strength. Now we can see amines are the organic compounds which are the derivatives of ammonia. So amines, when you see, they are the derivatives of ammonia. NH3 is lone pair donor, and it is going to be H plus, it is going to give rise NH4 plus. So it is going to be a base and it is going to be conjugate acid. Brown said Lowry acid base theory. And you can see the primary amines are NH2 and H plus, and it is going to give you R NH3 plus. So the lone pair electron donating ability makes this is a base. Okay, so I just want to say basic strength is directly proportional to tendency to donate lone pair. Tendency to donate lone pair of electrons. Okay, 1 minute please. Yes, it is. No. It is. Now, the basic strength is directly proportional to tendency to denote lone pair of electron on the nitrogen. So, in the gaseous phase, basic strength is directly proportional to tertiary is greater than, secondary is greater than, primary is greater than ammonia. Okay, but in the aqueous phase it is given in the NCERT directly. It is all depends upon the steric factors, it all depends upon the hydration factors, and all depends upon the various factors. If the group is a methyl group, secondary is greater than, primary is greater than, tertiary is greater than ammonia. This is a super important point, and this is purely based on NCERT data, and based on this you are expected to get a question. And if the group is other than methyl group, it is going to be ethyl, and secondary is greater than, tertiary is greater than, primary is greater than ammonia. It is going to be a very important point. So this is all about, whenever you said, you have to consider the aqueous phase only. It is all depends upon the aqueous phase. Okay, unless it is mentioned that is a gaseous phase, you can't use this, right? It is all about the aqueous phase. I just want to say alkyl amine is more basic than, in general, alkyl amine is more basic than ammonia is greater than aryl amine, aniline. That also we will discuss in today, right? Now let's talk about the mesomeric effect. So it is all about the resonance now. So up to here we might have completed in the previous class. So now we are going into the mesomeric effect, is also called as resonance effect. I want to say mesomeric effect or resonance effect is the application of a resonance on the property of the molecule. So let us say any effect, Tribeni, yeah, any effect which triggers the resonance is a mesomeric effect, where this is, you can see a group, let us say chlorine is there, it is attached to the benzene, so it is attached to a conjugated system. So what happened, the electron is moving from here to here, so this is what is called as a positive mesomeric effect. When you talk about nitrobenzene, so you can see the nitrogen oxygen is more electronegative and this electron is withdrawn away from, this is what is called as a negative mesomeric effect or negative resonance effect. So what I can say here, any effect that withdraw the electron from the benzene by virtue of resonance is a negative mesomeric effect, and the resonance is the key point for that. What are the essential conditions to say resonance can happen or not? So the system, the molecular geometry is supposed to be planar, it should be in one plane and there should be a conjugation, and a system or a lone pair or a pi bond or a pi bond and a pi bond and a pi bond and a positive charge and lone pair and a positive charge, whatsoever it may be, should be separated by one sigma bond is called as conjugation, and these are the essential condition ताकि इसका resonance possible होता है. Okay, Tribeni Roy. So let us talk about the trick to understand the positive mesomeric effect and the negative mesomeric effect. So it is pretty simple, I just want to say, pretty simple I want to say, if a group that is attached to the benzene and this element is going to have a lone pair of electron, and this lone pair of electron should give the electron to this. The lone pair is the key point, the electronegative atom should carry the lone pair, ताकि this is going to show the positive mesomeric effect. That is the trick I just want to give you, my dear students. And you can see here, and let us say element A and B, there is a electronegativity of B is greater than A, so that the pi bond is shifted towards B and the electron is going away from the benzene, that is negative mesomeric effect, negative mesomeric effect, you understand? So this is the positive mesomeric effect and this is the negative mesomeric effect, are you getting or not? So let us see the effect of this positive mesomeric effect and the negative mesomeric effect is following the order OH, OR, NH2, NHR, NR2, SH. When you see the lone pairs can be visualized like this, you can see the lone pairs. So जहाँ पर lone pair आता है ना, वहाँ पर आपका positive mesomeric आता है, right? Whenever positive mesomeric effect happens, the benzene ring is going to be activated and it is going to be ortho and para director in this electrophilic aromatic substitution reactions. Wherever you can see electron withdrawing group minus R or minus M effect, you can see a multiple bonds are seen. Multiple bonds are seen when you check the structures. Okay, C double bond O, H, C double bond O. So this is a multiple bond makes, it is a negative mesomeric effect. This negative mesomeric effect is going to withdraw the electron and deactivate the benzene ring, and it is going to be para director. Understand? Sorry, meta director. Hi Asif, hope you are understanding Tribeni. So use the chat box to say any type of doubts, you please let us know. Now let us see important common order of acidic strength. So it is a generous order for any effect, you can say. Sulfonic acid is more acidic than, carboxylic acid is more acidic than, phenol is more acidic than, methyl alcohol is more acidic than, water is more acidic than, alcohol is more acidic than, alkyne is more acidic than, ammonia is more acidic than, and alkene is more acidic than alkane. Always it is very important. Okay, and you can say a strong acid can have a weak conjugate base and a weak acid can have a strong conjugate base, right? So the acidic strength, I just want to say its conjugate bases are SO3 minus or COO minus and phenoxide ion and methoxide ion and OH minus ion and RO minus ion and CH triple bond C minus ion and NH2 minus ion and CH3 minus ion. So these are all the conjugate bases. A strong acid will have a weak conjugate base and vice versa. So what happened? Basic strength, इसमें ज़्यादा एसिडिक है, इसका बेसिक स्ट्रेंथ कम होगा, है कि ना? सुपर ऑसम ट्रिक, इट्स ए सुपर ऑसम ट्रिक. इसका एसिडिक स्ट्रेंथ कम से कम है, इसका बेसिक स्ट्रेंथ ज़्यादा से ज़्यादा होगा. So the order of the basic strength is going to be like this, and surprisingly you are going to observe alcohol is less acidic than water. Yes, of course. लेकिन methanol is more acidic than water. You understand? Clear? Fine. Next, yes. Now let us talk about applications of mesomeric effect on the acidic strength and basic strength. It is going to be a super awesome thing. Effect of electron withdrawing group, effect of electron releasing group on acidic and basic strengths. Let us talk about electron withdrawing group increases the acidic strength and decreases the basic strength. And electron releasing group decreases the acidic strength and increases the acidic strength. Okay? Fine. Now let us see. Arrange the following order in decreasing the acidic strength. So phenol is acidic. Why? Let us talk about this is your phenol and it is going to be your phenoxide ion. It is going to be your phenoxide ion. Yes. Let us see. This is a conjugate. This is a weak acid. And it is going to be conjugate base. So you need to have a proper method to crack a question in the NEET examination. इतना लंबा method नहीं चाहिए, but in the explanation it is important to know what is the actual order it is. So this is the conjugate base of this. Okay. Now let us see here. O minus, its resonance structure I just want to give you. Carefully you see. And it is given like this. So it is a resonance stabilized. So kya? So I just want to say a negative charge is coming over here. Okay, it is a structure, right? Negative charge is coming over here, right? Carefully observe. And it is going to be A negative charge are given here. So you are going to see this again. So what do you understand from these resonating structures? I just want to say, right? So carefully, Ingelia Raj. Now in this resonating structure, negative charge is here, negative charge is here, negative charge is, so charge delocalization takes place. If any electron withdrawing group is attached over here, any electron withdrawing group is attached over here, electron withdrawing group or electron withdrawing group, stable, right? If electron releasing groups are given, already negative charge is electron withdrawn, stable. If negative charge is there, electron is released, unstable. It is going to be unstable. Hayas, hello. Yes. So, what could be the answer for this? Let's say here NO2 group is going to have negative mesomeric effect as well as negative inductive effect. So, my dear students, whenever inductive effect and mesomeric effect is there, you always consider inductive effect. When it is talking about the methyl group, it is going to have, it is a positive inductive effect. This positive inductive effect is making unhappy, and it is going to have the positive mesomeric effect, you can see. Positive mesomeric effect. So, it is positive mesomeric effect. Of course, inductive effect is there by sigma bond. Okay. So, chlorine is having, whenever halogens are coming, consider its inductive effect only while deciding acidic nature and basic nature. Okay, don't consider its very weak mesomeric effect because of high electronegativity. So I just want to say consider inductive effect. So I wanted to say my dear children here, acidic nature is directly proportional to negative mesomeric or negative inductive, and acidic nature inversely proportional to negative mesomeric effect or negative inductive effect. So this is the rule, thumb rule, everybody should have in your hand. So you are going to say 2 is greater than, 5 is greater than, 1 is greater than, 3 is greater than 4. Are you getting or not? Are you getting or not? Ayaz? Injilela Raj? Yes, of course. It is done. So this is how I can present you the question, I can display the answer, I can say A, B, C, D, blah, blah, blah. But I am giving you the actual concept, how to engage this question in a systematic way, scientific way, ताकि आपका जो NEET examination में you never do mistake. Agree with me? Tribeni? Ayaz? Yes, of course. Okay, let's see. Arrange the following in decreasing order of the pKb of conjugate base. pKb of the conjugate base mean to say directly it is, see the trap here. So acidic strength increases, Ka value increases, pKb value decreases. है क्या ना? Now it is going to have which effect, you see? It is going to have positive mesomeric effect as well as negative inductive effect. उसमें ये consider करना पड़ता. It is going to have negative mesomeric effect and negative inductive effect. उसमें ये consider करना पड़ता. And it is going to have, of course, negative inductive effect. So So based on this you can say which is going to have a carboxylic group. Let us talk about this here. As I said, it is negative inductive effect, mesomeric effect. Mesomeric effect is considered, and negative inductive effect, negative mesomeric effect. Yes, it is a negative mesomeric effect. मैं बोला ना? So it is considered the negative mesomeric effect. Yes, yes, Raj, it is. And inductive effect, it is a weak effect. We don't consider this. Whenever halogen comes, we consider only inductive effect. So you are going to get 3, 4, 1, 2. Your answer is really appreciated. Angelila Raj and Tribeni, where are you? Where are you? Asif, Ayaj, come on. Fine, 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 fine. Now let's see one more question and a series of questions and logics. A question and a logic, a question and a logic. You are going to have a dump of information at the end of the session, and everybody take a pen and paper and write these valuable examples, and you can correlate it to your NEET examination preparation. Undoubtedly you are going to get a straight away 2 questions from the general organic chemistry. So definitely you can do it. Be confident. अच्छा सोचो अच्छा होगा, है ना? Fine. Next. Okay, for acidic strength, मान लो हमेशा acidic strength is directly proportional to Ka, inversely proportional to pKa. And acidic strength is directly proportional to stability of conjugate base, and inversely proportional to basic strength, and inversely proportional to Kb, and directly proportional to pKb. Ayaz, yes. These are the key noteworthy points I wanted to give you guys. And also for basic strength, इसका थोड़ा उल्टा करना है, logic सब logic उल्टा होगा. Basic strength is directly proportional to Kb and inversely proportional to pKb. हाँ. And basic strength is directly proportional to stability of conjugate acid is directly proportional to 1 by acidic strength is proportional to 1 by Ka is directly proportional to pKa. Everybody take this logic into the action. Come on. लिख दिया? So that we can have a class. We can have a question based on that. Yes, yes, yes. Now, which of the following is more stable? So, उसमें एक carbocation दिया गया. Okay. Here this is a positive, this is a positive, this is a negative, and this is a negative. Okay. So, what do you understand? The stability of the carbocation, whatever the stability. So, ये दोनों में कौन सा stable होगा? बस. There are 2 questions, not a single. This is not a single question. There are 2 questions. And this is a question and this is a question. This is a question and this is a question. Let us bifurcate this. Okay. There are 2 questions. ये दोनों में कौन सा stable होगा? अब बताओ. जल्दी. Ayaj. When you talk about the stability of a resonating structure, you need to talk about a neutral structure is more stable than charged structure. So, दोनों न्यूट्रल स्ट्रक्चर नहीं है, चार्जड वाला है. ओके, दोनों न्यूट्रल स्ट्रक्चर नहीं है, चार्जड वाला है. सो द नेक्स्ट स्टेप कम्स इनटू द ऑक्टेट. यू हैव टू कंसिडर ऑक्टेट. ओके, सो दैट इज द रूल नंबर 1. रूल नंबर 2, देन यू चेक द चार्ज. राइट. सो कार्बन जो है इसमें यू कैन सी कार्बन इज हैविंग कार्बोकैटायन 6 electrons. Okay, and here carbon is simple, so everybody is octet. So that 2 is greater than 1. Are you getting or not? Your answer is correct. And here it is 8 electron. इट इज ऑल्सो 8 इलेक्ट्रॉन, सब 8 ऑक्टेट सफिशियंट है। अगर ऑक्टेट सफिशियंट होने तो आप चार्ज देखना पड़ता। ओके, कार्बन लेस electronegative, oxygen is more electronegative, negative charge on more electronegative is more stable, that is the reason why यहाँ पर भी 2 is greater than 1। समझ में आ रहा है क्या बेटा? Are you getting or not? Are you getting or not? Clear? Now let's talk about given order of stability. So now we just given two things started. Now we are into the deepest 1 2 3 4 5. So everybody start solving along with me and give the answer in the chat box. Jaldi jaldi. Charge separation, charge delocalization, neutral structure is more stable than charged structure. So structure 1 सबसे ज़्यादा stable है। Okay, and charge separation and charge delocalization. Charge separation highly unstable, charge delocalization highly stable. Okay, so what happened here? In the first there are a maximum number of pi bonds and it is neutral as well as neutral, therefore it is more stable. समझे समझे। And second one 2 and 5, second structure and fifth structure, the number of pi bonds is equal but charge separation is greater in, charge separation is greater here। Okay, so that charge separation हमेशा कम stability देता है। Are you getting or not? Therefore we can say 2 is more stable than 5। I wanted to say पॉजिटिव चार्ज नेगेटिव चार्ज बीच में डिस्टेंस बढ़ते जाएगा एंड स्टेबिलिटी कम होगा। ओके, डिस्टेंस कम होगा, स्टेबिलिटी ज़्यादा होगा। दिस इज द फंडामेंटल रूल, दिस इज द फंडामेंटल रूल। आर यू गेटिंग और नॉट? क्लियर? And whenever you just see positive charge and a positive charge or negative charge and negative charge, उसमें distance कम होगा, stability कम होगा। So two similar charges cannot be on the side by side carbon atoms। आसानी इंग्लिश में। Okay, two similar charges cannot be side by side, highly unstable। Okay, therefore you can say, and 3 and 4 you can say it is highly polarized where carbon is octet insufficient, here it is also super destabilized। negative charge side by side आ रहे हैं ना, so this is never exist, never exist। Okay, now it is you all can see me now, right? Fine, it is going to be a super awesome important example for your NEET examination preparation. Never leave this, and this is the logic. Whenever dissimilar charges are there, the distance between dissimilar charges increases, stability decreases, and the distance between the dissimilar charges decreases, stability increases. Opposite charges, distance decreases, okay, and similar charges, distance decreases, stability decreases. That's very, very, very important. Okay, now let's talk about one more. Hurry, give the order of stability of the following resonating structures. Here O minus, and it is C minus and N minus. So सारे के सारे charged structures का है। Now we have to consider the negative charge on more electronegative atom is supposed to be very good and acceptable, and a positive charge on the less electronegative atom is going to be not acceptable. Anyways, the electronegativity of this is going to be oxygen is greater than nitrogen is greater than carbon. So the stability O minus ज़्यादा होगा. So that stability O minus is greater than N minus is greater than C minus. Are you getting or not? So that O minus is greater than N minus is greater than C minus. So the answer is going to be 1 is greater than 3 is greater than 2. Clear? That's good. Very important. Okay, we'll go into the more details. Now, hyperconjugation. What is this hyperconjugation? Aditya Bharadwaj. Yeah. So, in the hyperconjugation, it is called as Baker-Nathan effect, or otherwise called as a no bond resonance. So, when you see this is the carbon to carbon double bond. So, when respective to this carbon go to carbon double bond, it is going to be said to be alpha carbon, and the hydrogen attached to the alpha hydrogen, and this is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen. Alpha hydrogen pakadna kaise hai? So hyperconjugation is a key point. Hyperconjugation is a key point which can exemplify the stability of carbocation, carbon free radical and alkene. So to see the stability of such kind of compounds, you need to focus on more hyperconjugation. Hyperconjugation is happening with alpha hydrogens. So what happen when the carbon and the carbon, if it is with sigma bond with hydrogen, and this is the pi bond with sp2 carbon, and this sigma and pi lateral overlapping is called as hyperconjugation. So this hyperconjugation happens in the carbocations, carbon free radicals and alkenes. So the stability of these three can be explained on this basis of this number of alpha carbons, and it can have no bond resonance. I don't want to give you such a resonating structures. You need not have to draw these structures even. Okay. So application, stability of alkene, stability of alkene. So more the number of alpha hydrogens, more will be the stability. Okay, more will be the hyperconjugation and more will be the stability. Okay, stability of alkenes is directly proportional to number of hyperconjugation structures is directly proportional to number of alpha hydrogen atoms. Number of alpha hydrogen atoms. Are you getting or not? Aditya Bharadwaj. Okay. So, if you can see here, this is the structure 1. Carbon to carbon double bond, a carbon to carbon double bond. Now, the carbon that is directly attached to this hydrogen that is directly attached to the carbon is not alpha carbon. Carbon that is directly attached to the carbon is alpha carbon. So there, if you understand, you can handle hyperconjugation in the examination point of view. Now this is alpha and this is alpha. So there are 3 alpha carbons and each alpha carbon contains 3 alpha hydrogens, so that 3 plus and 3 total 9 alpha hydrogens are seen. Clear beta? Now we can see carbon to carbon, you don't consider this, you don't consider this, and you don't consider this, and you have to consider this only. I can find only one alpha hydrogen, you can see. So as compared to this alkene, I would say 1 is more stable than 2. Are you getting or not? It's very, very, very important. Clear? Very, very, very important. And one more, as far as this carbocations and the alkenes are concerned, and some more titles are there and slides I just want to show you. Tribeni, not asking any doubt. Aditya Bharadwaj. Ayaj, Ingelela Raj. So let's go ahead. So the stability of carbocations, you can see this is alpha carbon, this is alpha carbon, so that you are going to get alpha hydrogens, 9 alpha hydrogens are there. So this is the tertiary carbocation is more stable, and you can have 6 alpha hydrogens. It is going to be more stable than primary, only 3 alpha hydrogens, and it is going to have methyl, no alpha hydrogens. That's the reason why the carbocations Rupal, yes, Rupal, hi. So generic order of the stability of carbocations, tertiary is greater than, secondary is greater than, primary is greater than methyl because of this. Because of this. In general, I just want to say order of stability. Trophylium carbocation is more stable, then benzyl carbocation is more stable, allyl carbocation is more stable, and tertiary carbocation, secondary carbocation, primary carbocation, methyl carbocation. Okay. So this is the general order of stability of the carbocation you need to know. And once it has been asked, there is a debate between these two, who is going to be more stable. Of course, whatever I have given, you follow that order. Okay, benzyl is more stable than allyl is more stable than tertiary. Okay. Now let's go into the details. So electromeric effect, after that all the things once again will come across with that. Okay. So electromeric effect is observed in the presence of an attacking reagent, and therefore it is a perfectly temporary effect. जितने देर ये reagent उसमें है reaction mixture में, ये polarization आपको दिखाई देते हैं. Now we can say this is of two types, positive electromeric effect and a negative electromeric effect. That is a different matter. So what I mean to say, when the pi bond is shifted away, when the polarization occurs in the presence of an electron, attacking reagent is called as electromeric effect. In this electromeric effect, this attacking reagent attacks where the pi bond is shifted is called a positive electromeric effect, and the pi bond is shifted away from the atom where the electrophile, so attacking reagent is attacked, that is called as a negative electromeric effect. So this electromeric effect is absolutely reversible effect, and it is a strong effect, and it is a purely temporary effect. This effect lasts as long as the attacking reagent is present in the reaction mixture. Are you getting or not? Rupal, doubts? Aditya Bharadwaj and Ingili Laraj and Tribeni Roy, Ayaj, many students are there. Abhinav, I wanted to expect you in the class. Maunika is also there. Okay, anyways, let's talk about benzoic acids. So, acidic nature of benzoic acids and phenols and alcohols and basic nature of amines and many more things still has to come out. Yes, no doubt. Got it, right. So, here substituents are there. So, COOH and benzoic acid orthohydroxy and meta hydroxy and para-hydroxybenzoic acid. Here I just want to say OH group is having negative mesomeric effect and a negative inductive effect, whereas it is going to have negative mesomeric effect and negative inductive effect, but negative mesomeric effect is not observed. Why? Because at meta position resonance never operates, my dear students. It's very, very important. Only inductive effect is going to be operated. That's the reason why sirf minus m likha hua. Aura king. Okay, you're a big fan of? Okay. Here is also negative mesomeric, negative inductive and a positive mesomeric effect. Okay? So what is the expected order? So नेगेटिव इंडक्टिव इफेक्ट की वजह से मेटा ज़्यादा होगा बेंजोइक एसिड से. थैंक यू वेरी मच, थैंक यू. एंड आर्थो इज ग्रेटर देन पैरा बिकॉज आर्थो के नेगेटिव इंडक्टिव इफेक्ट इससे ज़्यादा होगा. दैट इज एक्सपेक्टेड. सही नहीं है. एंड सही क्या होगा? What is the actual order? But in the case of the base of ortho isomer, we have intramolecular hydrogen bonding. So there is an ortho effect. I'll show you. Steric inhibition of the resonance. Ortho effect. Okay. So ortho effect क्या होगा? This is your benzoic acid. Okay, this is a group. So any ortho substituted benzoic acid is more basic. मोर बेसिक चाहिए. ये जो ग्रुप है इलेक्ट्रॉन विड्रॉइंग ग्रुप हो सकता है, इलेक्ट्रॉन रिलीजिंग ग्रुप भी हो सकता है. Any ortho substituted benzoic acid is more basic. Understand? By default of that, you can say ortho benzoic acid, ortho hydroxybenzoic acid ज़्यादा से ज़्यादा acidic होगा. Then you can use the other logics. Dr. Chopra, you are a benzoic acid and you tell me you are more acidic than me or more basic than me. You tell me. Okay, anyways, hope you understand this. This is ortho effect. It is a super important effect. This effect you apply only for benzoic acid derivatives. Fine? Now let's talk about one more. Substituent चाहिए, नाइट्रो ग्रुप हो गया. Of course, it is going to be ortho effect. So ortho ज़्यादा से ज़्यादा स्टेबल होगा. ऐसे शुरू करो. Right? Very good. Aditya Bharadwaj, Aura King, Chopper. Now you can say it is going to be सिर्फ negative inductive effect होगा. It is going to have negative mesomeric effect, फिर भी negative inductive effect भी होगा. So that ortho is more than, para is more than, of course, meta and benzoic acid. Are you getting or not? Expected, maybe it could be anything. Aura King, got it? Clear? Yes. Now one more. If the substituent is methyl group, so I just want to change these groups. So pick this ortho and apply ortho effect. Ortho, Kushi Sharma, high. So ortho is going to be the more acidic. Now don't look at the other effects. Okay. Now it is going to have minus I effect and plus I effect and plus HC stands for hyperconjugation. Now we can see ortho is more than benzoic acid because these electron releasing effects and hyperconjugation is more effective than inductive effect. So this para kam se kam hoga. So this is the order. So this kind of orders are pretty important for NEET examination, and everybody take a pen and paper and write all the examples, and it is going to be a super awesome confidence for your NEET examination, right? Getting benefit of it, right? Next, if it is a halogen, first whenever benzoic acids are given, consider ortho effect. Push the ortho effect over here. So ortho ज़्यादा से ज़्यादा acidic होगा. Then consider negative inductive effect. Negative inductive effect मेटा में ज़्यादा है, पैरा में कम है, क्योंकि ये inductive effect distance dependent होगा. So it is going to meta, para and benzoic acid. BA stands for benzoic acid. Are you getting or not? Clear? Kushi Sharma, and we'll jump into another concept. Aditya Bharadwaj, Rupal, yes, very good. Now phenols. Now we'll talk about the phenols. So what is this phenols? So let us talk about this here. Yeah. Orthonitrophenol, metanitrophenol, paranitrophenol. So in these nitrophenols, don't apply ortho effect over here. Okay, ortho effect is the effect that you can visualize only in the case of the benzoic acids. But of course here also in the different way it is happening. In the ortho you are going to see negative inductive effect, negative mesomeric effect, negative inductive effect because meta position, mesomeric effect resonance doesn't operate. In the para, inductive effect and mesomeric effect. So it works. Now what happened here? What we expect, it is going to be ortho is greater than, para is greater than, meta is greater than phenol. But there is some magic is happening in this. Orthonitrophenol, this is your phenol and this is going to be nitro group, है ना? ये nitro group जो है इसमें एक इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग होगा. ये इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग का वजह से आपका जो हाइड्रोजन है ना, ये इसमें अटक जाएगा. So it is going to be trapped inside it. Therefore what happens, that proton, that H plus do not come out. So that what we expect, O, P, M and phenol, but P is greater than ortho. It is exceptional order. जहाँ पर exception है वहाँ पर question आने का ज़्यादा संभावना भी है. So everybody focus on this kind of exceptions. Definitely you are going to get a very good chance of the NEET examination. Fine? Got it? Great, great, great. So we'll see some more things quickly. Rupal, Aditya Bharadwaj, Kushi Sharma, Aura King, Chopper, right? Got it. Very wonderful. Now let's see. Substitute agar phenol, ortho, methyl, metamethyl, paramethyl hoga to. So it is going to have positive inductive effect and positive hyperconjugation. सिर्फ positive inductive effect. Hyperconjugation is just like a resonance only, and it is going to have a positive inductive effect and a positive hyperconjugation. So what happened? Expected order and actual order दोनों में सही होगा. So it is going to be phenol is more than, meta is more than, para is more than, and ortho. Got it? Clear? Now let's see, if this group is a halogen, halogen हमेशा नेगेटिव इंडक्टिव इफेक्ट आता है. Okay, so the order is going to be, you don't consider this, only you consider this inductive effect. Inductive effect. Inductive effect is going to be distance dependent. Inductive effect is distance dependent. As distance increases, inductive effect decreases. So it is inductive effect उसमें ज़्यादा होगा, इससे कम होगा, इससे कम से कम होगा. So ortho is greater than, meta is greater than, para is greater than, and कम से कम phenol का acidic strength कम होगा. Are you getting or not? Clear? Any doubt? Very good. Now, anilines, aminobenzene is called aniline. मान लो fundamentally, alkyl amine is more basic than, ammonia is more basic than aniline. Okay, that's very important. So when the substituent is a OH group, here you never have kind of ortho effects and all. So steric inhibition of resonance will be there, that's a different version, we will discuss it later. And it is orthohydroxy, it is going to have a negative inductive effect and a positive mesomeric effect. Positive mesomeric effect is होता है, as it is a positive mesomeric effect, है ना? And it is going to be a negative inductive effect, ghost king, hello. Funny name. And it is going to have negative inductive effect as well as positive mesomeric effect. Whenever inductive effect and mesomeric effects are there, consider only positive mesomeric effect. Okay, and among this, whenever positive mesomeric effect is coming into the picture, its basic strength बढ़ जाएगा. So in that negative inductive effect, इसका basic strength is going to be decreased. So whatever we expect, and it is going to be the same. Para and greater than ortho. Para is greater than ortho, is greater than aniline, is less than greater than meta. So inductive effect का काम इसमें कम से कम होगा. Are you getting or not? So positive mesomeric effect increases the basic strength, है ना? So that it is going to be ortho is greater than para, right? Now let's see some more things over here. Yes, if it is a halogen, it has inductive effect as well as mesomeric effect. When it comes to the mesomeric effect for the halogens, never consider mesomeric effect, consider only inductive effect. And it is going to have meta position inductive effect ही चलते हैं. So meta position resonance कभी नहीं operate करेंगे, and it is going to be negative inductive effect and positive mesomeric effect का काम नहीं होगा. Okay, now expected order and actual order is going to be the same. Aniline is greater than, para is greater than, meta is greater than ortho. So negative inductive effect decreases the basic strength. That's the reason why all will have the less than aniline. Understand? Clear? So अगर कुछ डाउट है ना तो जल्दी से जल्दी पूछो. Use short box for interacting kind of things, huh? Yes, got it? No doubt. Very good. Now, aniline, orthonitro and metanitro, paranitro. Nitro group has negative mesomeric effect, negative inductive effect. So that nitroanilines are going to be less basic as compared to the aniline. So I just want to say here, aniline is a super basic as compared to the meta, सिर्फ negative inductive effect चलता है. लेकिन positive mesomeric effect, mind it, mesomeric effect is not actually the effect due to distance. Mesomeric effect is the effect is anywhere, okay? Whereas inductive effect is distance dependent but not the resonance effect. Okay, got it. So here you can say inductive effect यहाँ पे कम होगा, inductive effect यहाँ पे ज़्यादा होगा, so that more negative inductive effect decreases the basic strength. Ortho कम से कम होगा. Are you getting or not? Clear? Now substituent COO chona to. Oh, you see the combinations that I am giving you. You can revise the total organic chemistry based on this general organic chemistry. Can you believe it? So YT YouTube में whenever we are discussing something, it can be colorful, right? But when it comes to the genuine content, definitely this is the best platform I can say. Everybody please like, share, subscribe to Infinity Lane YouTube channel. हम इन्फिनिटी लेंस से बच्चों लोग के लिए कुछ भला करने का कोशिश कर रहा हूँ, ओके? सो ये फ़ायदा उठाने का कोशिश कर रहा हूँ, ठीक है? ठीक है, पेन एंड पेपर, सॉल्व अलॉन्ग विथ अस. Bharadwaj, come on. Aniline, COOH group, COOH group has a negative mesomeric effect as well as negative inductive effect. And here going to get meta, it is going to be negative inductive effect, and it is a para, it is going to have negative inductive effect and negative mesomeric effect. Okay, so negative mesomeric effect का काम ज़्यादा चलेगा, so that aniline का basic strength ortho and para में कम से कम होगा, so that you are going to have aniline is greater than meta and para ortho में negative inductive effect उसमें ज़्यादा नेगेटिव इंडक्टिव इफेक्ट होगा, सो दैट आर्थो बेसिक नेचर कम से कम होगा, राइट? क्लियर? Okay, some more questions are there. Getting ready for that. Stability order of carbocation also is there. बच्चों now, if the group is methyl group is going to have positive hyperconjugation and a positive inductive effect, है ना? So hyperconjugation इसमें कैलकुलेट करना पड़ता है, and सिर्फ माइनस आई इफेक्ट पॉजिटिव इंडक्टिव इफेक्ट, पॉजिटिव हाइपरकॉन्जुगेशन, यहाँ पर सिर्फ पॉजिटिव इंडक्टिव इफेक्ट ही होता है. So that the actual order is going to be ortho is greater than para is greater than meta is greater than aniline. No, but actual thing is para is greater than meta, ortho में कम से कम होगा. Okay, because of the steric inhibition of resonance is very, very, very important. Why so? Why so? Why so? This is super important. So carefully you see, basic strength is directly proportional to stability of conjugate acid. Stability of conjugate acid, है ना? So let's talk about the stability. So this is aniline paramethyl. If it is added with H plus, you are going to see NH3 plus. CH3. Now what happens, let us zoom this structure here. Nitrogen, it is tetrahedral. there is a repulsion between these two because of this steric inhibition of resonance. It is unstable. Whenever it is unstable, equilibrium always stay in the backward direction. Hai ke na? Equilibrium always stay in the backward direction. That's the reason why ortho is less stable. In the NEET examination, my dear students, you are going to get assertion and reasoning type question. Assertion and reasoning type question. Are you getting on? Clear? Fine. This is a super important point. Bharadwaj. Yeah. Now, the correct order of acidity of the following compounds. You tell me the questions. General organic chemistry topics are done. Yes. Now the question is for you. I want to know the answers from the students. COOH, C2H2, H2O, ROH. What is this order? In the generous order. I have given you the generous order. Remember? Yeah. Give the answer for you. So that is going to be D. Carboxylic acid is greater than water, is greater than alcohol, is greater than acetylene. Okay. And the generous order, I just want to go you back. Everybody, focus here. Remember this, the generous order. Carboxylic acid is more than, water is more than, alcohol is more than acetylene, right? So the same can be used there. The same can be used there. Carboxylic acid is greater than, carboxylic acid greater than water, greater than alcohol, greater than acetylene. Got it? So the answer for this question is going to be D. If you have any doubts, please let us know so that we can have a discussion in the class, right? So if you want to have this kind of discussion, so you need to expend a huge amount of money and go to the coaching center and this. But in this YouTube channel, we are allowed to ask a doubt and every doubt is going to be explained on the board. So take this golden opportunity and solve the questions. Okay, come on. Next question. Which of the following acids does not exhibit optical isomerism? Lactic acid, tartaric acid, malic acid, alpha amino acids. What is lactic acid? So let me write the lactic acid structure here. COOH. This is your lactic acid. This lactic acid contain chiral center. It will show. It will show, right? Now let us talk about the tartaric acid. This tartaric acid you can see COOH, and let us take a mesotartaric acid or D-andyl tartaric acid. As it is not mentioned, you can take any of the structures like this. Now this is optically active. And alpha amino acid, this is optically active. Except glycine, all alpha amino acids are optically active, except glycine, I would say. Okay. So malic acid, what is this malic acid? CH COOH double bond CH COOH. This is your malic acid. It is a cis isomer. It shows geometrical isomerism and not optical isomerism. Then इसका trans क्या होगा? And it is going to be like this. This is a trans isomer. इसका नाम क्या है? Fumaric acid. It is going to have fumaric acid. Are you getting or not? Clear? Any doubt? So now C. Answer is going to be C, malic acid. Do not show optical isomerism, rather they show geometrical isomerism. No doubt. And next one, mesotartaric acid is optically inactive. Really? Yes, of course. And optically active molecule is a molecule that cannot be superimposed on the mirror images. Of course. Yes, of course. Let's talk about yes. If the reason is false, but assertion is true. So, mesotartaric is optically active. Of course, kaise? Let us say COOH and OH and COH and COOH. So this is your mesotartaric acid. Mesotartaric acid is optically inactive due to plane of symmetry. POS. Due to plane of symmetry. Due to plane of symmetry, internal compensation takes place. Due to internal compensation, this mesotartaric acid is optically inactive. Okay? Due to internal compensation. So, this statement is wrong. Bharadwaj, Rupal, Kushi Sharma, Aura King. Hi Kushi. Ghost King and Tribeni. Right. Next question. The order of basicity of the halides. Order of basicity of the halides. So, always use our fundamental laws. A strong acid will have its weak conjugate base. That is a fundamental rule. Anywhere in the chemistry we can use this. Right? Anywhere in the chemistry we can use this. Now let us follow the acidic strength. Acidic strength HF, HCl, HBr and HI. As the size of the electronegative atom increases, it is going to be a strong acid. So acidic strength will be in this way. And once they lose their H plus, you are going to get F minus, you are going to get Cl minus, you are going to get Br minus, you are going to get I minus, right? So it is the weakest acid, it is going to see the basic strength, you are going to see the basic. Weak acid will have strong basic strength, understand? Clear? Wonderful. Next, answer is going to be A. F minus is greater than I minus is greater than Br minus greater than Cl minus. Dear students, participate in the chat box and present your answers so that decision taking tendency is going to be increased. Okay. So when NEET examination is going on, you have to take a decision, right? So in these live classes, when you give your answer in the chat box, your decision taking tendency is going to be drastically improvised so that you are going to get a super awesome things, right? Fine. One more question. Get it? Yeah. So aniline, para-nitroaniline, meta-nitroaniline and benzylamine. So among the following, the strongest base. Use your logic. We discussed about this. Use your logic. Bharadwaj expecting answer from you. All the students who are online, please. So as we discussed, arylamine, alkylamine is more basic as compared to the ammonia, is more basic than arylamine, aniline. So this is the funda, right? Now do you think this amino group is directly attached to the benzene? No, it is alkylamine, benzylamine. So that alkylamines, of course, they are going to be more basic, so it is going to be D. So solve the questions by using the simplest logics in the class. So that tendency can increase you the answering abilities in the NEET examination. Okay, feel it is an exam and you do it. Fine? Any doubt? Next. Next question, increasing order of basic strength of this. Let us use again our logic. A strong acid will have weak conjugate base. Let us talk about their acidic strength. HCl is greater than CH3, COOH is greater than H2O, right? And F minus is also given here, F, HF, right? Now their corresponding ions, their basic strength is going to be A, so that you are going to get Cl minus, okay, and F minus less than CH3, COO minus less than OH is going to be the strong. It is A. How do you say? Bharadwaj, you gone wrong. You just correct it. A strong acid will have the weak conjugate base. Hai ke na? A strong acid will have weak conjugate base. Don't say sorry. Okay, you correct yourself. ये काफ़ी इम्पॉर्टेंट है, ठीक है? Yeah, got. So everybody is good at subject only, my dear children. So my intention in this live class is to just abruptly, I just want to remove all your confusions. Agree with me? Next question. So which of the following exhibit optical isomerism again? Now so far you are in acidic and basic, all of a sudden you jumped into isomerism. So that versatility you need to develop it. So the answer is going to be you are going to see chiral center. If a compound has only one chiral center, you are going to get optically active. Okay, no? So it is going to be option B is the correct answer for this question, right? Fine. Next question. You solve it. Next question. Among these canonical structure, the correct order of the stability. Khalil, hi, good afternoon. What is the answer for this question? Jaldi, make it fast. Khalil. So, rule number 1, neutral structure is going to be more stable. This is a neutral, right? And then the charged structure. So, one is more stable. When it comes to the charged structure, negative charge and a positive charge. Here, for your clarity, this is given negative, this is given negative and a positive, and a positive and a negative, right? So, positive charge, carbon is not octet, okay, carbon is not octet. So, 6 electron on the carbon, therefore, it is not stable. So, 1 is more stable, 3 is more stable, 2 कम से कम stable होगा, right? So, Sheikh Khalil, the answer for this question is going to be C. Clear? That's perfect. That's perfect. Next question. Again, which of the following molecule pi electron density is minimum? So, pi electron density is going to be maximum wherever you have positive mesomeric effect is there. Minimum whenever negative mesomeric effect is there. You have positive mesomeric effect. You have a positive mesomeric effect. You have a positive mesomeric effect. And you have negative mesomeric effect. So, negative mesomeric effect की वजह से इसका pi electron density on the ring minimum कम से कम होगा. So, the answer for this question is going to be A. Got it? Got it? So, Aditya Bharadwaj, you come out of your confusion and discuss with us. Sheikh Khalil and what? That's good. And let's see one more example. Ease of ionization to produce carbocation and bromide ion under the treatment of Ag plus will be maximum in which the following compounds. Aditya Bharadwaj, I want to give the answer. I want you to give the answer. Jaldi, make it fast. Expect Aditya Bharadwaj and yes. Whenever it is ionized, it is going to give rise Br minus and a carbon plus. And whenever it is ionized, you are going to get carbocation, right? Whenever it is like this, and whenever it is like this. Option C. Okay. So, I would say this is a vinyl cation, this is allyl cation, and this is a benzyl cation. But one thing you missed it. What is that? This is cyclopropyl, cyclopropene, cyclopropenyl cation, which is aromatic. Which is aromatic. So aromatic का वजह से ज़्यादा stable होगा. So that I would say A is greater than, C is greater than, allyl होगा, P is greater than D. D कम से कम होगा, vinyl carbocation कम से कम stable है. Then what basis this cyclopropyl carbocation is aromatic? That's very important, noteworthy point. Sheikh Khalil, Aditya Bharadwaj. Fine? Okay. For your convenience sake, I would say the answer is going to be A. Let me give you a little confidence about the aromatic nature. About the aromatic nature. If we want to say a compound to be aromatic, you need to know the compound supposed to be cyclic and planar. Compound supposed to be cyclic and planar. And it should have a complete delocalization. And it should obey Huckel rule. So 4n plus 2 should be equal to number of pi electrons. Calculate the number of pi electrons and put it in this equation, solve for n. If n is equal to any integer, 0, 1, 2, 3, any integer, it is going to be aromatic. If it is a decimal number, it is not. Okay. So, you want to say a compound to be aromatic? Let's see here. So, aromatic and non-aromatic and anti-aromatic. So, the compounds can show cyclic and planar, this has to be obeyed, and complete delocalization, means the resonance should be completely within the cycle and it should obey Huckel rule. Then only a compound to be certified as an aromatic. If an non-aromatic, this may be true or false, this may be true or false, you don't have to check this. Okay. So, I want to say If the compound is cyclic and planar and complete delocalization is seen, but unfortunately Huckel rule is not obeyed. In that case, you can say it is an anti-aromatic. So when you talk about this aromatic and non-aromatic and anti-aromatic, the relative stabilities of the aromatic, non-aromatic, anti-aromatic compounds comes in this way. Aromatic is going to be super stable, then non-aromatic is stable, and of course anti-aromatic is super unstable. Such compounds never exist. Whenever you write a reaction in that category, it is going to be anti-aromatic, so that you never form such type of compound. So this is the order. Everybody take a snapshot. It is going to be a super trick for your NEET examination. Aromatic, non-aromatic and anti-aromatic. Okay. Clear? Now let's go back to our questionnaire. Yeah, we completed up to here, and we'll discuss some more questions for you. Ready for that? Sheikh Khalil, Aditya Bharadwaj, Tribeni, come on, be confident. Now, let's talk about one more. It's such a logical question. So, minimum number of carbon atoms required to be present in an optically active alkene. Optically active alkene. So, I just want to take carbon CH3, carbon CH2 and CH3 and H and CH3 and CH2 double bond CH. Now, what do you understand? You are going to be getting this. Clear? So, उसमें कितना नंबर कार्बन दिख रहे हैं? ये ऑप्टिकली एक्टिव कंपाउंड है. 1, 2, 3, 4, 5, 6. So, my answer for this question is going to be 6. Got it? Simple. It's pretty simple. Got it? Okay, one more question. Keto-enol tautomerism is not observed in. कीटो-इनॉल टॉटोमेरिज्म एग्जिस्ट करने के लिए कम से कम एक अल्फा हाइड्रोजन होना चाहिए. या सो C6H5, you don't have alpha hydrogen in that. You don't have alpha hydrogen in that. Okay. So it will not show. This will show. Okay. It is going to be answer A. So we are in this isomerism, acidic nature, basic nature, stability of carbocations. So आगे आने वाले हैं. Which of the following conformations of butane is the most stable? So let us talk about the stability of the butane. Four major so CH3 and hydrogen and hydrogen, 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 and it is going to be CH3 and CH3, hydrogen and hydrogen, and it is going to be Right. Hi, Anushka Rai, I was missing you. So this is fully eclipsed. It is Gaussian. It is partially eclipsed. And it is anti. So the stability anti is greater than Gauss is greater than eclipsed greater than fully eclipsed. Are you getting or not? A, D, C, B. Na Anushka Rai, you are going to get, yeah, anti is more stable. Correct. That's perfect. That's perfect. Anti is more stable. So, ADCB, yes, of course, fully eclipsed. Or eclipsed, or simply say it is the partially eclipsed. Are you getting or not? Clear? Now one more. Yes, it is A. Among the following optically active compound is, again you have to. Among these optically active compound, yes. ऑप्टिकली एक्टिव कंपाउंड्स कौन सा होगा? Whenever it has a chiral center, it is going to be optically active. Let us talk about the structure. CH3 and CHOH, and it is deuterium, it is going to be chiral center. So that I would say this is optically active. This is optically active. Anushka Rai, when you come now, the chart is going to be raised with very good number of questions. And my answer is going to be C, correct. Khalil, come on, Bharadwaj. One more question. The maximum number of possible optical isomers in the 1-bromo-2-methyl cyclobutane. 1-bromo-2-methyl cyclobutane. It is going to be cyclobutane. Cyclobutane is a square-like structure, and it is 1-bromo-2-methyl. So, 1 position and 2 position. You are going to get 1-bromo-2-methyl, whatever. You are going to get cis trans isomers. One can be given in this way, another can be given in this way. It is going to be a trans isomer. So, when it comes to be, it is asked a maximum number of possible optical isomers. So, you are going to have one cis, and this is a cis and this is trans, and this will have plus and minus isomer, and this is going to have a plus and minus isomer. Total how many isomers are seen? I could see 4. So, the answer for this question is going to be 4. Clear? Very good. And 1-bromo-2-methyl cyclobutane optical isomers, there will be 4 cyclyl. Your answer is absolutely correct. What about Anushka Rai? Very good. So, in today's class, we discussed about a very good number of concepts and questions in the total general organic chemistry. In one shot, it has been completed. Students also got, yes, students also got very good confidence, and day after tomorrow, we are going to meet with hydrocarbon part 1. So there also I just want to discuss about very good concept and very good number of logical questions, so that in this journey of NEET one shot series you are going to get a super booster for your NEET examination. So stay tuned and please like and share and subscribe to Infinity Learn YouTube channel, and thank you very much. Yeah, solutions practice bhi hoga. Everything, whatever you want, you please put in the chat box and comment box, so that we are going to come up with a tailored and we are going to give the tailored catering for the subject. Okay. Hi, Sheikh Tahera, Anushka Rai, very good. Bye and signing off. We are end of the session. Thank you very much. God bless you. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Bye bye. Thank you.